So now we're going to start what we call discriminant problems. So these are just harder examples of quadratic inequalities, but we'll go through them in this video and they should make sense. They're not too hard, they're just a little bit harder than the ones we were doing. We really recommend watching Algebra 19 Roots of Quadratics, which is a video we made a while ago. So just go back in the playlist to look for this video. And yeah, it'll just give you a good base of what we're talking about when we're talking about the discriminant. So I'll just give a tiny quick review. It probably wouldn't be enough if you haven't seen this in a while. So again, just recommend looking at that. So the discriminant is b squared minus 4ac. And so I called it the determinant in that video by accident, but it's called the discriminant. Discriminant. Okay, and the discriminant tells us about the nature of roots. So I'll just, again, quick summary. So we're going to have three different types of roots. So these are the three different types of roots you can have for quadratic equations. They can either hit it twice, hit the x-axis only once, or they can hit the x-axis 0 times. Yeah? So those are the three different types, and the discriminant will tell us which one of these it is straight away. So I'll scroll down and write a few notes. So we call this having two separate roots. Yeah? So it hits the x-axis twice. So that's called two roots. This is called having just one root because it only hits the x-axis once. One root. And this is called having no roots. Okay? So this is a real solution, or there are real roots. Again, this as well means that there are real roots. And if there are no roots, it means they're imaginary or not real. Okay? So imaginary roots. And so that's just important. If it's imaginary roots or not real roots, that means it doesn't hit the x-axis. And then the last thing to say as well is, I'll do this in a different color, and I'll go red, that if there are two real roots like this, then b squared minus 4ac, so the discriminant, will be greater than 0. Okay, and that's the whole point. So it'll tell you the nature of the roots without having to graph it out. Okay, so b squared minus 4ac will be greater than 0. And if it's one root, then b squared minus 4ac will be equal to 0. And if there are no roots, then b squared minus 4ac is less than 0. So this means it's minus. So the answer for b squared minus 4ac will be minus. This will just be 0. And this will be plus. Okay, so that's just a quick review of Algebra 19. So again, we'd recommend watching it if you want to get the whole, kind of just watch the whole thing, or like learn it all properly. Just a brief summary. But anyway, we're just going to run ahead with the example now. So the question is 2p plus 1 x squared plus p plus 2 by x plus 1 is equal to 0, okay? And they want to find, so it's the range of values of p that there are real roots. So again, so they want to find the range of values of p that this quadratic here has real roots. So depending on what p is, you might have a quadratic that looks like this, this, or this, and they want to find out what numbers does p have to be for it to be either this or this, so real roots. They want to find that it hits the x-axis, okay? So there's basically a particular method we're going to do for this, and it's just this following method here. So you know, for a quadratic, it's in the form ax squared plus bx plus c, okay? So that means that a is going to be equal to 2p plus 1, b is equal to p plus 2, and c is equal to 1. So does that make sense? So they're the kind of numbers before the x in this case. So the numbers before the x squared, numbers before the x, and then just a constant on its own. So these are the values. So we're going to have a look at the discriminant. So I'll go orange. So like we said, the discriminant. So if the discriminant b squared minus 4ac is greater than or equal to 0, that means it has real roots. Okay, so we want the b squared minus 4ac to be greater than or equal to 0. So b squared, if we look at this, it's going to be p plus 2 squared minus 4 by a is going to be 2p plus 1, and then c is just going to be 1, and greater than or equal to 0. So bear with for 1 second. We're going to square this. So it's going to be p squared plus 4p plus 4 minus 8p minus 4 greater than or equal to 0. And then we're just going to do this in, I'll go purple. So one more line, we're going to get p squared, so the plus 4 and the minus 4 are going to cancel, and then 4p minus 8p is going to be minus 4p is greater than or equal to 0. Okay, so now we basically just start with the old method. So once we have a quadratic in p, so that's what you want to do. You want to let the discriminant be greater than or equal to 0. You want to find a quadratic in p, so this is a quadratic equation with p, and now we want to do our normal method like we've done in the last few videos, except just with p. Okay, so I'm going to take it up to the top right for that. So p squared minus 4p. So I'm going to start here. We're going to have p squared minus 4p is greater than or equal to 0. So basically now we want to solve this. Okay, so it's just like any of the other questions we did. So the first step, we're going to say p squared minus 4p is equal to 0. Yeah? Then the second step, I'll go green, as we have to solve it. So the way we solve one like this is we factorize it. So we take p out, and it's going to be p minus 4 equal to 0 like that. And if two numbers multiplied by each other are equal to 0, that means one of them has to be equal to 0. So either p is equal to 0 or p is equal to 4. Yeah, so again, that's just kind of manipulating this, moving it around. So those are our two possible answers. So now the third step, I'm sure you know now, is to sketch it. So 3 is to sketch. So we'll go down. So p squared minus 4p, and it hits the x-axis at p is equal to 0, p is equal to 4. So it's going to look something like this here. Okay, where that obviously is 0, and this point here is 4. Is that okay? So again, it's just a normal quadratic. There's no plus before the p, so you just pretend that instead of p squared, you just have x squared. It's the same, it'll make the same graph anyway, is the idea. So now we have this graph here, and then the fourth step is again check OG question, and it's asking us where p squared minus 4p is greater than or equal to 0. So where it's greater than or equal to 0 means it's where it's above the x-axis. Yeah. So again, greater than means above the x-axis. So I'm going to scroll down again, and I'll go to bright blue. So above the x-axis is going to be anywhere over here or anywhere over here. So it's either going to be p is less than 0 or p is greater than 4. Okay, and those are our two answers for the first question as well. So it's the answers for this question, and then it's also the answer for this one here. So the range of values of p, that this equation here has real roots. So again, it's p is less than 0 and p is greater than 4. Okay, so hopefully that video made sense. It is a bit of a long one, and you do have to kind of know what you're talking about with these here. So again, we'd recommend watching Algebra 19 before this. All you have to do is let the discriminant, so b squared minus 4ac, be greater than or equal to 0. Then you sub your numbers in, you get your quadratic, and then you go back to the questions we were doing earlier. Okay, so the method, you have 1, 2, 3, 4. You find your answers, and there you go. So hopefully that summary made a little bit of sense. Hopefully the question in general made sense. But it is the very same method every single time, so you can learn the method off if you aren't so certain about it. Not that we'd recommend that, but sometimes it just has to be done. Anyway, I hope you enjoyed that video, and we're going to talk about rational inequalities next. So it's inequalities with fractions in them. Yeah, so we'll see you then. There should be a box here you can click to go straight to the next video.